The first is the string, which is the data type that represents free text. It's one of the most commonly used data types since it's so versatile. You can have letters in it, combined with numbers, special characters, etc., etc. Here's an example. Here we create a new string variable and call it user ID. Notice on the right that we're setting this variable to a standard Salesforce ID value. Salesforce IDs often include both letters and numbers, making it a perfect candidate for a string. When using strings, here are a few tidbits to remember. First, strings are always surrounded by single quotes, not double quotes. The first trigger I ever wrote didn't work because I used double quotes, and it took me 8 hours to figure that out. Use single quotes. Next, even though strings are versatile and can pretty much store anything, it doesn't mean that you should always use it. Use the data type most closely matching your value. For example, we can store integers in strings, but if we try to add those integers together, we'd get some pretty unexpected results. Adding strings together literally places them side by side in a single value. The best analogy for data types is field types for custom fields in Salesforce. A string variable is similar to these field types, and you'll often store the values of these types of fields in strings. Again, a super versatile data type. Now let's talk about secret methods. One of the big reasons data types are so interesting is because each data type has its own batch of secret methods. You can easily capitalize strings using the capitalize method, for example. This would make absolutely no sense if attempting to do this on an integer data type. You can also check if a string contains a certain value using the contains method. These are just two examples of secret methods on strings, and we'll go into more detail when we cover dot notation later. For now, just know that each data type has secret methods that will blow your mind. Next up, we have our friend the integer data type, which stores numbers without any decimal places. You can create integer variables just like this. Notice in the second example that 3 minus 1 computes to 2, which is also an integer. So even though we're not explicitly setting this variable to an integer, the result of the statement is an integer, and that's good enough. Some tips. First off, notice how I did not use single quotes around the numbers. That stuff is for strings only. Next, if you even try to store a decimal value in an integer, you're gonna get an error. You might try to be clever and try to trick your code and do something like 3 divided by 2, but in the end, integers only store numbers without decimal points, so your number is gonna get rounded down. In terms of related Salesforce field types, the number field type with no decimal places is the brother of the integer. Unfortunately, integers don't really have any nifty secret methods. Well, one less thing to worry about. Decimal, the next data type, is the older sibling of the integer. It's a little bit more refined. Of course, the differences are you can store numbers with decimal places in a decimal type variable. Here are a few examples. Notice how we can have a varying number of digits after the decimal point. No need to specifically define the number of decimal places beforehand. Salesforce will automatically scale the proper number of decimal places to give you a super accurate number without any data loss. You can also store integers in a decimal variable. And because of that, if you're in doubt between choosing from an integer and a decimal, play it safe and go decimal to prevent potential data loss. All of these field types match up well with decimals. And one secret method of the decimal data type is the round method, which rounds your decimal up or down to the nearest integer. The date, a data type that's so useful in code. Dates represent calendar dates in code. Here's an example of a date variable. There's not really a good way to type out a specific date in a way code can understand. So when you're creating date values, you usually have to use special methods like the one here, date.today. For example, let's say you wrote out 3/3/2010 as a date. Apex really wouldn't know how to process that. Is it a string? Are you dividing 3 by 3 by 2010? Is the first number the month or the day of the month? All confusing things to a computer. So when creating dates, you'll have to rely on a few special methods. Dates have so much built-in functionality, using them really makes your life easier. For example, Salesforce takes care of all time zone conversions for you. So convenient. In fact, pretty much all of the automatic functionality you get when using a custom date field, you also get when using a date data type. And the secret methods of the date data type are a lot like the date formula functions you get in custom fields. For example, adding days to a date. Salesforce knows how many days are in each month, so it can calculate the exact date for you. New instance is an important secret method because it lets you choose any date you want. You'd use this method here if you wanted to construct a March 17th date in the year 2020. Another neat method is the isLeapYear method. Salesforce will tell you if the date you have happens to fall in a leap year. Amazing. Date times, the older sibling of dates. Not only do date times track dates, they also track the time of the day and the time zone. You can create date times similarly to how you create dates using special methods. Note that date times are super precise and able to track a time down to the millisecond. And don't forget, Salesforce does all the time zone conversions for you. So if a date time isn't what you're expecting, it's most likely because Salesforce already converted the time zone for you based on your user settings. Again, all the functionality you get in DateTime custom fields is available to you in the DateTime data type, and more. Special methods include formatting your date time to the GMT time zone, adding seconds to your time, and extracting the hour from your date time. The date time is a powerful, powerful data type. And then we have the Boolean, really the baby of the family, the absolute simplest data type. There's only two values, true and false. I love it. It's so easy. True or false, that's it. Notice in these Boolean examples that we set them to true and false, and neither value is wrapped in single quotes. Those two words are reserved keywords in Apex, so Apex knows exactly what they represent. It can be tempting to use strings as Booleans and simply wrap true or false in single quotes, but don't take the bait. I sometimes see this with inexperienced programmers, and it simply amounts to unnecessary work and confusion. True or false, no single quotes. That's all you ever need with Booleans. Checkbox field types in Salesforce are just like Booleans, and experienced admins know that you can also create a pick list with true and false as values. But, like in code, that just introduces unnecessary work and potential confusion. Booleans are so simple that there aren't really any unique methods for it. I couldn't even make one up if I tried. The final primitive data type is the SObject, the big daddy of them all. It represents a record in Salesforce from an object of your choice, custom or standard. This is probably the data type you'll be using most often, and you've probably already used it by now even in simple triggers. Here are a few examples. Notice that we don't actually use SObject as the data type. We use a specific object in Salesforce. SObject is just a general word we use, and the S in SObject stands for Salesforce. We can use custom objects as well as the data type, just don't forget the _C after it. To the right of the equal sign, we can create new records to assign to our variable. We can also use existing records and assign them to our variables, but we won't cover how to do that until later on in this course. You and SObjects are going to be working a lot together, so I suggest you two become friends now. As for related field types, there are none in Salesforce. It can be tempting to consider lookup or master detail relationships to be parallels of SObjects, but remember that those fields really only store IDs. So those fields are usually stored in strings, not SObjects. This will become more obvious to you as you code more and become exposed to how Salesforce works underneath the hood. Some secret methods that all SObjects share are clone and clear. Clone makes a copy, and clear erases all field values. That covers the main primitive data types in Apex. We just covered a ton of information, and don't worry, you're not expected to have memorized all that. You'll pick these up in your muscle memory in no time.